Welcome to Daily Papers, the podcast where we break down the latest and most interesting research papers into something you can actually understand.
Today, we're diving into the world of online shopping and those sometimes great, sometimes weird recommendations you get. You know how you might use an app like DoorDash or Uber Eats to order from restaurants all the time, but the moment you click on their grocery or retail section, it's like the app has no idea who you are?
Exactly. Suddenly, it's recommending you cat food when you don't have a cat, or a single banana when you've never bought fruit online in your life. It's a classic issue that tech companies are constantly trying to solve.
And that's the perfect setup for today's paper. It's from a team at DoorDash Inc., and it's called Mind the Gap, Bridging Behavioral Silos with LLMs in Multi-Vertical Recommendations.
It sounds complicated, but the core idea is brilliant and tackles that exact problem. So first things first, what's a multi-vertical platform?
It's just a fancy term for a platform that sells different types of things. DoorDash started with restaurants, that's one vertical. Then they added groceries, which is another vertical. Then alcohol, then retail items, you get the idea.
And the behavioral silos part of the title refers to how our user data is often trapped within each of those verticals. The app knows a lot about the kind of restaurants you like, but that knowledge doesn't automatically carry over to help it recommend groceries. Your behavior is stuck in a silo.
This leads to what's known in the industry as the cold start problem. When you're a new user in the grocery vertical, the recommendation system is starting from scratch. It's cold. It has no data, so it can't give you good, personalized suggestions.
So how do you warm it up? How do you give a user good recommendations right from the get-go? That's what this paper is all about. The researchers at DoorDash proposed using what they already know about a user, their restaurant order history, to predict what they might want from other verticals.
And their tool of choice for making these predictions is the technology that's on everyone's mind, large language models, or LLMs. We're talking about the AI brains behind systems like ChatGPT.
Right, these models are incredibly good at understanding patterns in text. So the researchers basically fed an LLM a user's order history. Imagine telling it, okay, this user has ordered chicken tacos from Taco Bell, a butter chicken from Royal Spice, and a cheese quesadilla.
Then they ask the LLM to act like a recommender engine and infer the user's general tastes. Based on that order history, the LLM might come back and say, this person seems to like chicken, cheese, and specialty breads like naan.
And those tags, chicken, cheese, specialty breads, become new pieces of information, or what data scientists call features, that describe the user. These features can now be used to recommend items in the grocery store. Suddenly, the app isn't starting cold anymore. It has a pretty good idea that you might be interested in buying chicken breasts, a block of cheddar, or some pita bread.
But they didn't just let the LLM guess wildly. That can lead to the AI making strange, unrelated suggestions, which is something researchers call hallucination. They needed a way to control the output and make sure it was accurate and relevant.
And this is where their secret sauce comes in. The method is called hierarchical retrieval augmented generation, or hierarchical RAG for short. It's a mouthful, but let's break it down.
First, hierarchical. The team has a massive internal catalog of all their products, organized in a hierarchy, like a family tree. It might go from a very broad category, like dairy and eggs, down to a more specific one, like cheese, then even more specific, like hard cheeses, and finally all the way down to cheddar.
So when the LLM looks at your restaurant orders, it doesn't just guess a random product, it works its way down this hierarchy. First, it identifies the top-level categories you're interested in, like dairy. This part is the retrieval augmented bit. The model is retrieving information from this pre-approved list of categories to augment or improve its response.
Exactly. It's like giving the AI a set of guardrails. Once it has high confidence you're into dairy, it then drills down to the next level to figure out what kind of dairy. This step-by-step process makes the final suggestions much more precise and keeps it from going off the rails.
The researchers also created two different profiles for each user. One is a long-term affinity profile, which is built from all your past restaurant orders. It captures your general, long-standing tastes.
And the other is a short-term intent profile. This one is based on what you've recently searched for on the app. If you just searched for yogurt, that's a very strong signal that you want yogurt right now. This captures your immediate, in-the-moment interests.
So they combine these long-term tastes with your short-term intent to create a really rich picture of you as a customer. This new, detailed user profile is then fed into their main recommendation model, which is a multitask learning model.
Which just means it's a smart system that's trying to project multiple things at once. Like, will the user click on this item? Will they add it to their cart? And will they actually buy it? By learning all these tasks together, it gets better at its main job, which is ranking items in a way that's most helpful to you.
Okay, so the theory is solid. It sounds incredibly clever, but the big question is, did it actually work when they tested it?
It did, and the results were really impressive. They compared their new system, enhanced with all these LLM-generated features, to their old baseline system. For the overall user population, the new model led to about a 4.4% improvement in ranking quality. In this industry, an improvement like that is a really big deal.
And what about the most important group, those cold start users who were new to the grocery section?
That's where the new system really shined. For those users who the op previously knew nothing about, this new method of transferring knowledge from restaurant orders made a huge difference. They saw a significant performance lift, proving the model was successfully bridging the gap between those behavioral silos.
That's fantastic. It means your love of tacos and burritos can finally be used to get you a good recommendation for salsa and avocados in the grocery aisle.
So what's the big takeaway here? This paper shows a really practical and powerful way to use LLMs. It's not about writing an email or a poem, it's about using AI as a kind of semantic bridge or a translator to understand a person's preferences more deeply and transfer that understanding from one context to another.
It's a smart solution to a common problem, making these giant all-in-one apps feel a little more personal, a little more smart, and a lot more useful. It's a great reminder that the power of this technology lies in how creatively we can apply it to solve real-world challenges.
And that's all the time we have for today. Thanks for tuning in to Daily Papers. Join us next time as we explore another new idea changing our world.